In this video, we're continuing our discussion of lesson 2-5. Right now, we're going to be talking about the higher order derivatives. So the idea here is that since our derivative was just another function, we can take the derivative of that function. That would give us the derivative of a derivative. And then we could do that again and again and again. These derivatives are called higher order derivatives. Order referring to how many times it's being done, higher being, again, we're going higher and higher in the differentiation process. So here's the notations you might see for these things. The first derivative, the one you're most familiar with at this point, y prime or f prime. These two are the Newtonian notations for Isaac Newton. dy dx or ddx applied to a function, the Leibniz notation. Not super important you know those terms. This is much more useful when we're talking about slope or when we want to avoid ambiguity, because one little tick mark here can look like a lot of different things to a lot of different people. So the second derivative, we're taking the derivative of the derivative. So these two notations make the most sense, I think, are the easiest to understand. It's sort of that we have y prime, and then we're going to take the derivative of that. So that's y double prime. Same thing with f double prime. Over here, this is where students really don't like it, the Leibniz notation, notice that the square is on the d on the top, and the square looks like it's on the x on the bottom. So it's actually on the dx. What's happening there is that we have dy dx. Okay. It's actually easier if you look at the f, but I'll do it the hard way. And we're going to take the derivative of this function. So parentheses, believe it or not. So d, we'll go with the d. So we're taking two derivatives of y, and dx is treated as one variable, just like d is treated as one variable. And that's how we get that. Easy to read. 2 means second derivative. Just be careful how you notate it. Third derivative, 1, 2, 3 tick marks, 1, 2, 3 primes. Fourth derivative, and here we start putting the number of tick marks in parentheses rather than just writing out 4 tick marks. So y with the fifth power in parentheses would mean the fifth derivative. This could also be written as y to the third, like that. You should not say y to the third, it's the third derivative, but that's how it would look in the similar notation down there. These all look the same. They're nice that way. That should be a big hint for one of the homework problems. Careful, careful. Here we go. Let's try an example. So, for f of x equals this nastiness, they're asking me to find f prime of 1 and f double prime of negative 8. F double prime, the second derivative of f, evaluated at negative 8. So to do this, we're going to need to take the first derivative and the second derivative. So the first step is to rewrite f of x 1 over 2, and I'm going to combine these to make 1 power. The cube root of x squared is x to the 2/3 power. And then, of course, I do not want the x on the bottom. I do not want the power on the bottom. So this is still f of x is 1/2 times x to the negative 2/3 power. So let's find f prime, the first derivative. We're going to take the power, negative 2/3, multiply it with a constant out front. Negative 2/3 times 1/2 is negative 1/3. x, negative 2/3 minus 1, negative 5/3. Now we could go off and evaluate this, or we could take the second derivative. To evaluate this, and notice how I took the derivative and then plugged in 1. If you plug in 1 and take the derivative, you will always get 0. Not just in this example, in any function. Because then you would be taking the derivative of a constant. So it's very important that we take the derivative and then evaluate. So f prime of 1 is just replacing all the x's in this function with 1, negative 1/3, 1 to the negative 5/3, 1 to any power is 1. So f prime of 1 in simplest terms is negative 1/3. That means the slope of f at 1 is negative 1/3, the slope of f's tangent line. Now, when we go to take the second derivative, again, we're starting from here. We're starting from the first derivative. We're not starting from this, because that derivative would just be 0. So f double prime of x, looking at this, bring the negative down. Negative 5/3 times negative 1/3 is positive 5/9 times x, negative 1/3 minus 1, negative 5/3 minus 1, negative 8/3. F double prime of negative 8, just replacing the x with negative 8. And that would be a fine answer if you weren't being asked to evaluate it. I'm going to review right now how to evaluate that with negative exponents because it seems to give many students trouble. I'm still going to label this side. Notice how all my work is labeled, just to keep it organized. 5/9. And now, when you have the option, you should always try to do the 1/3 power first. Actually, I'm gonna start by moving the fraction to the bottom. Sorry, moving the power to the bottom. I think that's going to be much more clear. So 5 over, we're going to bring this into the denominator. The inside stays the same, the power becomes positive. Careful. You have the choice. We're going to do the 1/3 first. The 1/3 is the cubic root. The cubic root of negative 8 is negative 2 to the 8th. That's 5/9 times on the bottom. Negative 2 to the 8th power is 256. And 256 times 9 is 2,304. And again, we just did that to show how you would simplify it if you had to. Any of these steps are just as good as the other, as long as you've gotten rid of all the variables. That's it for this video. Thank you for your attention. Good luck on the homework.